I'm Josh Gomez.
And I'm Jessie Frazelle.
We're from Kitty Cat, and we're here at Elevated Materials in Gardena, California.
They turn trash into treasure. They take upcycled carbon fiber and turn it into real usable parts.
Let's go inside. For everyone back home, could you both please introduce yourselves and give a little backstory about Elevated Materials, starting with you, Ryan?
Yeah, my name's Ryan. I started Elevated Materials in 2015, and our goal is to collect and upcycle all of the scrap carbon fiber material that's generated in the US and worldwide.
I'm Jaysen Harris, and I'm one of the co-founders and CTO. And I came onto the projects when I found out basically what the problem was, how we were going to solve it, all the different opportunities that were there, and it's been very exciting.
Before we get started, can you give a little bit, maybe like a fun story about way back when it was started? Maybe some very hard challenge that you had to overcome, or just something that you can think of way back then.
Yeah, actually we had a really interesting start. We launched our first Kickstarter campaign selling a skateboard, called it the Aileron skateboard. And when we first got started, we were originally going to have another company manufacture the skateboard for us, and we were going to work logistics and collect material from suppliers, bring it to this company, they'd press the skateboards for us. And we were about halfway through the Kickstarter campaign when they let us know that they weren't going to be able to do the manufacturing for us. And so fortunately, we were successful enough on the campaign that we were able to move into our own facility and start the production process ourselves, which helped us grow a little bit faster and take us further on that first round than we thought we were going to be able to do.
Yeah, that's really cool. I know I have one of the skateboards, not one of the originals, but the Rover from later, and then Josh just got one from Jordan. So
Pumped.
it's pretty exciting.
Pumped to use it.
Cool.
So I believe you started us off at the beginning of the life cycle. So should we go ahead and go through the entire process?
Yeah, we'll walk you through. So our factory is sort of set up like a U shape, starting with material coming in here and then working our way through the factory and then eventually coming back to this area where things ship out. So a lot of our incoming material, depending on whether something is spec'd or whether something's standard, we collect material in bags, we collect material on rolls, in boxes, material that's basically unusable for certain aerospace industry, and we unbag it and separate it out and sort of standardize the shapes so that we can use them in standard layups for blocks and sheets. So as we walk down the facility, we got different processing fixtures set up that allow us to cut those pieces that are otherwise too small to use in standard aerospace manufacturing into standardized shapes. And then those shapes get laid up into sheets.
Yeah, what you saw on the bags really was taking chaos. It's literally just, for these manufacturers, it's just in the way for that next piece that they need to make, that they need to cut out to move forward with their particular process, and they just need it gone. So that's where we really provide a solution for them. They know that we're going to destroy any intellectual property that's involved. We're going to work with their facilities and make sure that we're collecting on a timely manner so that we can get the material before it goes bad, because it will go bad at room temperature very quickly, within days to weeks, just depending on the material composition.
Oh, wow. I didn't realize that it would go bad.
I also did not know that. And then it's unusable. You can't do what you're doing
and then
right now.
at that point, so once there's a resin system in the material that's slowly curing over time, and you can slow that cure down by freezing it. So a lot of times you hear about carbon fiber being stored in freezers, but at room temperature, it can last anywhere from a week to a month generally. And in a freezer, it can last somewhere in the range of a year. And generally, we try to work with manufacturers to collect that material and turn it into a stock piece of material within a week time frame.
Wow, that's nuts. It's like milk.
Yeah.
The best thing for us is if we can collect it and run our process efficiently so that we don't have to freeze it. But there are times when we get a large amount of material and then we have to figure out what we're going to do with that, where we're going to store it cold, either on site or off site, to make sure that we don't let any of the material go bad.
That's nuts.
Could you bring it, so say you bring it out, you start working on something, and then maybe something happens and you need to store it again. Can you put it back in the freezer, or is it, okay.
Yeah, one thing about freezing it though is you want to keep moisture off of it. So when it gets frozen, it has to be put into bags so that the condensation that appears on the material is outside of the material and just on a bag.
Oh, wow.
Got it.
Which means we also have to plan when we're going to do production. If we pull it out, we need to give it time to come back to a ambient room temperature so that it doesn't have that. So we'll often have to just have that planned out the day before. We need to make sure that we have that material ready to go.
Now we've got a new process that we're really excited about, which is taking material that would otherwise be entirely unusable and turning it into machinable blocks. And it starts off with this sort of chaotic edge slit material. We separate this stuff from the backing paper and compile it into pieces that get then crushed into blocks.
That's
Super
cool.
dope.
Yeah. This is coming from a production line of the material itself, where the other material that you saw would be after the first consumer uses the pieces that they need. We're actually helping the manufacturer at this point now with their waste stream. Again, this is just in the way. They need to get rid of this material so they can provide what they're actually selling. And the customer who buys these needs them to be very precise in the width. And that's why it's called edge slit. It's that leftover material that they know that they're going to have to consume, not be able to sell, just throwing it away at this point. All this material was destined for landfill, and the material breakup is significantly other backing paper, the substrate that it goes down on. But we're able to, with our process, tease that material out and do it in a timely manner to be able to actually help this waste stream problem as well.
Yeah, that's dope. And you use the press back there? Or
Yeah, so we put that into press 5. There's a block tool in there right now making a part. Yeah, lots of pressure.
We do a lot of things where we iterate. We test out. The first one we did was a 6x6. We had to figure out the particular process. We got a little bit of trade secret involved there of making sure that we can consistently make it. And in this industry, the big thing is porosity or voids, imperfections, because it's all about the heat and pressure to consolidate into a solid mass. So we had to really come up with and iterate some designs and get to the point where we can actually sell that as a product or make parts out of this
make
material.
porosity-free parts.
Perfect every time, porosity-free.
Wow.
That's cool.
Yeah.
And so you're taking the scraps from other people and you are using it yourself. Are there any scraps that come from you? It sounds like we're getting so refined.
Yeah.
But is there?
At the moment, we have some waste material that we generate, and that's something that we plan to take in the near future and also convert into the blocks.
Whoa, dope.
Super cool.
Okay.
So yeah, all of our goal is to also be, zero waste.
Sure.
It's a work in progress.
Sure. I mean, it's still amazing
Yeah,
that you
it's
guys are taking the waste from others anyway, and you're still creating some valuable tools and products out of it.
Yeah, this is actually double duty, because the same process or the same solidification, pressing capability, we actually will be taking everything that we don't use with that other material, the flat sheets, that can then be used as a feedstock as well. So it's not just what we get in this form or different forms, but anything that we can't use in that laminate style, then just kick it right to this next process.
Awesome. We got the press 5. So what comes after the press 5?
Right, after press 5, just walking down the shop floor, we have press 6. This is our flat sheet laminate press. We're making 24 by 60 inch panels in the flat sheet press. They can range anywhere from paper thin, a 64th of an inch, all the way up to multiple inches, 2 or 3 inches thick, depending on what the customer requires. And some customers require recycled material, some customers require traceable in-spec material, and we do generally a good mix of both projects.
Nice.
So I have a question I was thinking of earlier, because you were saying this one presses up, and I was wondering why it wouldn't press down and use gravity to help it? Or?
The pressure is so much higher than gravity. We're putting 100 psi on it,
Okay.
and ultimately, like up or down, it is the same when you talk about the press because it's captured within a frame. So from
Gotcha.
a force perspective, you still have that force pushing down, but you also have the force pushing up. The reason that we have it pressing from the bottom to the top is for loading purposes. Some of our original press designs had the press platens coming down from the top, and we moved away from that design in order to make more available space to slot in different sheets. So this press is set up to do right now 12, but ultimately can be expanded to do up to 30 different laminates at a time.
Well, that's
Oh,
nuts.
wow.
Okay, cool.
Has a lot to do with just being able to quickly get the press open,
Ooh, yeah.
get in there, do what you need to do. Whereas if you're doing it from above, then you have to deal with trying to get that then expanded that same way.
Yeah,
it's really easy.
Exactly. You have a much more difficult time separating the tool plates if you press from above. But when you lift from the bottom, you can easily separate the tool plates.
Yeah.
Oh, cool. Okay.
Then you are using gravity essentially. In
Yeah.
hooks.
Yeah,
Yeah, nice.
Yeah.
that is true.
Another just iteration, lessons learned. Go to the next size, incorporate those designs. Like to do as many kind of figure out what works, what doesn't, and move on.
Yeah, fun thing about this press was it's actually our COVID build. When we did the lockdown for about a month, we designed and built this press.
That's so cool.
That's awesome.
Where do you even get parts for something like this?
We were actually able to source all the steel, and we outsourced some of the cutting, and we did some of the cutting in-house, and then for just a couple weeks, we welded things together, painted, assembled, pulled
That's so
parts
cool.
from old pieces of equipment.
It was interesting because it's significantly heavy, and it was really like tilting it up. That was the biggest thing. When it was time.
Oh my
Okay,
gosh.
well, we've assembled certain parts of it. It's time to actually get it on its feet. That was fun.
Yeah, picking things up with a forklift and like hammering bolts into place.
Yeah.
Yeah, that's like the
times.
opposite of an IKEA table where after you build it, you're like, oh, it's still hard, but this is so different.
What's really great about the material that we were able to produce here is that it is utilizing Ryan's expertise in the aerospace industry, where we're using the exact same techniques of customizing the way that the materials are placed and oriented, and the testing and defined thicknesses and flexibilities, which actually we got to learn that really early on, because our first skateboard you could actually order with different flexibilities, and it was a difference just in a few layers. It was kind of crazy how much different flexibility would change just based on Ryan's formulation, his design of those instructions on how to orient the fibers when we were building them.
That's really cool.
Yeah. So highly technical, very much that aerospace ethos.
So once we pull sheets out of the press, they make their way onto inventory racks, either stored as stock for customers to order in the future or put directly into a job on the CNC machines. So we stage our racks with different sheets for a given day of production, and then it is determined by our CNC operators and programmers whether a sheet's going to go onto CNC routers, water jet, or onto 5-axis CNC milling. And generally it depends on whether there are complex 5-axis features. If there's simple pockets, countersinks, taps, we'll run those on the router. And if it's a 2D profile, then we typically will cut that on the water jet. It all depends on tolerance requirements and customer specifications.
This is kind of like the handoff point, the composite side, the taking material, the waste, and everything else we need to create a sheet or a block. That staff does that. It gets pressed. It's no longer going to go bad. It's actually in its solidified, cured form. Then it hands off into, okay, well, what needs to happen next for someone who actually has ordered it? Ultimately, we want to move, or I would say, reclaim or keep out of the landfill as much of this material as possible. But in order to do that, we actually need someone to buy it. And people want to buy parts. They want to buy, and in the beginning it was skateboards, then it was, our discovery that drones, we did some first-person racing drones to start off because they're not super specific, or so we thought. Actually ended up being a pretty specific category of performance, and then using that and learning and pushing forward in discovering what people want to use this material for and figuring out how to get that to them. So it started with the water jet for the skateboards, and we just figured out every other way we could take something we could make and finish it, turn it into that part that customer wants. And that's really where this handoff starts. And there are customers who just want sheets. They're going to do all the machining, or they just want blocks. They're going to do all the machining for the particular projects, the parts they want to make. But then, so we'll ship those. That we love that. That's great. But we also love these really interesting projects because we can see all the ways that people are using the material, how much of the actual properties of the material get, are that advantage for those applications. And that's why we say it's like this U-shaped pattern. It gets to this point, and it makes its way through that next stage, which is actually making parts, making the product the customer wants.
Yeah, and there are also customers who want to learn how to make parts, where they start off ordering parts from us, bring in some CNC equipment, and then we're happy to train them on how to run CNC equipment and cut the material. Yeah. It's a tricky material to cut, but with the right cutting techniques, it's actually a really easy material to cut.
Interesting.
Cool. Yeah. We want to enable people to, pick this up and run with it for their own production. And so we will help them with tooling setup. We'll help them with actually the cam, and we have shared our knowledge about how we've done particular parts so that our customer could take that over. It's interesting because they actually will then come back to us and be like, you actually don't need to do it so well. You could back off this particular part of machining because, we found that you just don't need to do that many passes. It's essentially what resolution we're doing, and they're like, no, it's fine. You don't need to do that much. So it's actually a give and take, or a back and forth. They get started and they actually tell us things, and then we can kind of share that with everyone because we want to advance the entire capability of this material not being in a landfill and being a really great, end solution for somebody for what they're trying to do.
So in an ideal world, would you just want to make the sheets and the blocks and have them be in charge of this stuff?
It would be, we get to see a lot of really cool stuff.
Yeah, that's an internal debate for sure.
Yeah, we talk about it all the time, honestly. Yeah.
It's definitely faster for us to scale up block production and sheet production, but CNC machining is also really cool, and there's a lot of fun parts.
Yeah, it's a lot of fun.
Yeah.
And that's the thing is you also saw what we're making as examples, and then and every time we do some other technique, it's like the wheels start turning. Oh, we could actually use that for our own capabilities, and that's why there's so many pieces of carbon fiber around, because we're actually like using our own material to make our own production equipment to then make more material. It's really fun how that feeds back in.
Just in the time that I've been here today, I've seen so many things, or you guys have pointed out so many things that have been made out of the carbon fiber that I'm like, I didn't even think that you could make that. I didn't even think about this. I didn't think about this. There's a ton of things that you can make out of this material, which is really, really exciting.
We try not to have leftover material hanging around, right? Like we'd rather sell it to somebody, but it's never going to be 100% perfect. And what we usually are using is something where there's like a cosmetic imperfection. And why not just make use of it for ourselves? It's perfect for that application. And we actually get the advantage of we have equipment that's slightly lighter or stronger than it would be, and just looks cool. All those same reasons people want to buy the parts from us, we get the advantage back.
Anything?
Well, I know like you all have like carbon fiber all throughout the place, like little signs and stuff like that. And you made, Jenna was like, you have to mention they made the relativity sign for their office.
Yeah.
For the embedded sign, right?
Oh yeah, or sorry, embedded.
Yeah, we made the embedded sign. That one was cut on the water jet.
So.
I would assume like all signs would be done on the water jet, right?
No, it depends. Sometimes people want pockets where they don't want the cuts to go all the way through, and they just want letters, and then they fill them with paint or something, and so we'll do that on the router.
Got it.
I mean, we'll, like what we were saying, we want to get a part or get a customer basically come up with a way the customer is going to want to use the material. So sometimes we'll even cut non-carbon parts for them I'm thinking of a sign. That's why I was mentioning it, where we would cut plastic that white on black or white on checker for that signage, and it's it gets the job done. It's we'd rather be cutting carbon, but honestly, anything we can do to help a customer out, make it happen.
Sure.
Do.
That's cool.
You want to bring us details
Yeah,
about
we can look at the CNC. So we got new keyboard setup made out of carbon.
It's so dope.
We're waiting for Amazon to deliver the trackpads.
Mm-hmm.
Yeah, see, like simple things like this, where you guys just said, yeah, let's use our own stuff.
Mm-hmm. And this is all customized based off of Linux CNC. Jason's been building and programming the interface for this machine.
That's cool.
It does tool touch off, probing, countersinks, pockets, all probed to the perfect depth. One thing that's special about this room is that it is actually a paint booth, and we we have two types of dust collection for all the stuff that takes place out on the outside is all wet cutting, and so the dust is contained within water. And in this room, the entire room is vented through a filter wall, and all of the machines are set up with point of generation collection. So we have HEPA filter shop vacs collecting the dust that's generated during the cutting process, and then anything the 1% that doesn't get collected gets pulled through the filter walls.
Yeah, that's cool. I was wondering why this was sectioned off, but now I see it. That's
Generally,
so cool.
we want to reduce the amount of dust that ends up on the shop floor, and of course, we care about people's health, so we want to make sure all the dust gets collected.
Are these?
Ryan, you can actually see what in blue is actually 3D printed, Ryan. I don't even know how many revisions we've had of the different ones that we've made, but it's a custom dust shoe that allows us to really do a really good job of collecting the dust where it's generated, so it doesn't even get a chance. 99% of it or a significant amount is just collected right then when it's generated.
Yeah, and an integrated air blast to keep the tools cold and the dust flowing into the vacuum.
That's so cool. Yeah, I see the little thing going into it.
Yeah.
And it actually goes up and down for that. Actually, we'll bring it down when you're cutting, and then you can raise it up when you actually are doing anything with the tooling.
Yeah, pulls it up for tool change, for tool check, for probing, and then brings it down when the spindle turns on for the cutting.
This is cool.
That's cool. I thought like the machine came like that, but that's dope that you all built that.
No, the machine came as like rails, and we built it.
That's so cool.
Wow. Are these pickleball paddles?
We do cut pickleball paddles.
Awesome.
This drawer.
Oh, would you look at that?
Whoa, those are huge.
I didn't even think about this earlier when we were doing all the filming, but yeah, we have drawers of parts on this.
The pickleball is a situation where that's actually pretty unique in that most of the parts that we produce don't have that core. There's a core there.
Yeah.
Lighten it up, use less actual carbon. So
Yeah. Well, I don't know what
With
we're
the
supposed
extra
to
mile
say
for
about
that.
their
yeah, I'm not going to say what it
integrated
is.
specific
Yeah.
design.
Sure.
But they all, pretty much all of them have that. A lot of
Yeah,
sports
most of them
equipment
are
have
a
some
carbon
kind of core
laminate
in
with
there.
like a polypropylene core, and there's some special things that go on with these ones that make them unique.
That's cool.
And the customer in this situation is iterating as well and testing out, and we can turn around new designs for them pretty quickly.
Nice.
Do you like that phase the best? Like that kind of.
It's pretty cool.
Yeah.
Yeah. Ryan actually handles most of it, but it's still fun to see the process.
Mm-hmm. Yeah, on the other side, we have some wet cutting equipment. This is the block that we pulled out of the press this morning. So it's labeled, it's staged to cut into parts that are going to be loaded onto the CNC and cut by the robot. So this guy will make its way into about 36 different square pieces that'll get loaded and then cut into parts for a customer.
That stuff is so cool. Yeah, we were also talking about earlier, that's how you get the marbled look.
Yeah, so it's kind of the industry term. There's a lot of controversy in the industry about whether the term forged carbon fiber works or not. We like it because it sounds cool. I've also heard it called marbled carbon fiber, but we make these huge blocks and billets. So this one's like dovetailed, so it can be held. We're going to cut this one into a helical gear.
Nice.
And then for fun, we've been cutting some nuts and bolts just to show
They're so cool.
kind of some fun 5-axis operations. Because a lot of our customers, we can't actually share the parts. We're like internally, oh, this part is so cool,
Yeah.
but we can't, film it and show anybody. So
Sure.
we pick some fun stuff that we can cut and give away as samples.
Wow.
So yeah. Nut and
These
bolt.
are really dope.
And then, of course, this is our production on the top. We're going to be cutting about 500 of the part made from this block. So we've just been cranking these guys out.
I feel like if I was Iron Man, instead of getting like a marble kitchen counter, I'd do this.
Yeah. I've heard a couple times that it'd be super cool to make these into like tiles.
Yeah.
I was thinking that too.
For, countertops, like bathrooms maybe, or
Yes.
garages. I think it'd be sweet if it was a high-end car garage had a bunch of these 1 foot by 1 foot tiles all over the place.
That would be so dope.
So they make their way from that cart into this robot. And then the robot is a machine tending robot that loads and unloads the Haas. We do a 2-operation cut for most parts, where it's a 5-axis for the first operation, where it sits on a TRT, rotates around, cuts all the 5-axis features, and then the robot comes back in, picks it up, moves it onto the Op2 jaw, which will cut mostly 3-axis features. And then the robot comes back in, picks it up, and drops it back on the rack as a finished part. And it's cool because we're able to do 2 operations robotically loaded without much operator intervention.
For those that maybe have no manufacturing experience at all, can you describe what you mean by 3-axis and 5-axis like operations?
Yeah, so if you think about Cartesian coordinates, you have movement in the X direction, the Y direction, and the Z direction. So that would be 3-axis. And then you can add an additional axis of motion to each one of those by rotating around the X, the Y, and the Z axis. In the case of our machine, we rotate around the A axis and the X axis, which is known as the A axis, and then we rotate around the Z axis, which is called the C axis. So incorporating all 5 of those degrees of motion, we are able to cut pretty unique features
That's cool.
that you wouldn't otherwise be able to cut on a 3-axis machine that can only move in X, Y, and Z. Or you can take a lot of setup operations out where you may have been able to cut it on a 3-axis machine, but it would take 5 or 6 different setups to get at all the different angles for maybe some weird tapped holes or pockets that need to be put onto a part.
So like the threads on the bolts, that's definitely 5-axis.
The threads, it depends. So you can cut them with a 3-axis cutter if you use a specific style of cutter. But the 5-axis may let you use, a more regular cutter. But something like a helical gear would need to be cut on a 5-axis because the actual teeth of the gear curve. And so you can't just get in there with one angle. You kind of have to come at it and then like twist around the side of it.
If you want to break it down in a even more simple way of thinking about it, because it looks a lot like this, it's the idea that you have, let's say, piece of material, and the only way that you can take a block of a material and cut it, if you're doing 3-axis, is say you put it onto a drill press. A lot of people know what a drill press is. You can go up and down with it, and it spins, and you can move a part. There's only so much that you can do. You can get really fancy, like what Ryan was describing, where you might put something in that drill press or basically that spinning bit to get into certain features in that piece. But it's only when you actually can rotate the block till you really get the most sophisticated things done in that situation. And that's the upgrade from 3-axis to that 5-axis.
And there's definitely a lot of steps in between, like index cutting, where it can't simultaneously cut in all 5 axes. It gets pretty tricky to program when you are trying to make all 5 axes move simultaneously.
Oh yeah.
So, the simplest way I would put it is that when it comes out of the machine, any of the machines, it may not be exactly what the customer wants. There's only so much that can be done. you might need to do some things by hand or inspect or do those other things, and we have dedicated stations for that.
Oh, cool.
Yeah, once it's been deburred, we pack and ship, and then parts are off to the customer.
That's awesome.
So, not too many special things going on at the shipping station. It's mostly just, boxing and packing. Well, I guess it's hidden behind this welding screen right now, but nothing too exciting behind the welding screen anyway.
Yeah. I mean, you did make some custom things, again, just
Oh,
self-fabricating to actually make us more efficient is kind of interesting.
It's actually kind of hard to pack sheets of carbon.
The 2 by 5 foot sheet, especially when you start to get many sheets that you want to send all at once, can actually get heavy. I mean, the carbon fiber is light for its strength. It's the strength to weight ratio that's really important about carbon fiber. Mm-hmm. But if you have a lot of it, it is actually dense. So handling it appropriately, handling it in a way that doesn't burden our staff, we can package all efficiently for our customers, so we're not shipping one in a box. We can actually stack them. We decided that we really needed to make something ergonomic, and that's what Ryan really came up with here.
Yeah, so the idea is you stack 100 pounds of carbon fiber sheets and slide the box end on, spin it around, slide the box on the other side.
That's cool.
Basically just continually trying to improve our process, make it easier for everyone that works here. And, if it makes it easier, then the cost can come down for the customers.
So you just welded these things?
Yeah,
Yeah.
This isn't carbon fiber.
Yeah.
It's best to just weld this thing. For sure.
Yeah, sometimes, we always choose the material that's best. In some cases, steel is the right material, and we'll use steel. In some cases, carbon fiber is the superior material. In a lot of cases here, carbon fiber is the superior material.
Yeah.
So we'll use the material that makes the most sense for the application.
Nice.
Very cool. I just love that you guys make your own tools.
I love it, yeah.
That's probably the number one thing about Elevated Materials is we've been fabricating almost all of our equipment, and our Haas and robot that loads it is one of the first major equipment purchases that we've ever done where we haven't built it or been in control of the software that runs it. So,
How are you feeling about that? Is it rough?
it's good in some cases, and other times you're like, wow, I wish we could just make this one simple change.
Yep.
But no, it's good. We're pretty happy with the machine.
There was no way we could get to production in the timeline that the customer wanted for the reason that we got it in the first place, or the first product that we knew that we were going to make in a larger production method. Being able to run, lights out the way that we're doing, it was a fully integrated package, and there's a lot of value in that. Would we do it again for the next one? It's always a build buy decision, and it's just really what is required at that moment. Even though it can be fun to spec it out and do all the things that we do to customize, sometimes something on the off the shelf or factory direct gets the job done better. But it's just case by case.
Totally.
Have you ever sold one of the tools you built?
Yeah, no, we have. I don't think we've done anything. We definitely will share the knowledge about using and make recommendations. So things like the actual tools that we put into the machines, we want to make sure everybody knows, that they don't have to struggle, that they are using the best, what we think is the best part with all of the experience that we have, the best tool to get the job done. So we share a lot of that information. Would it be fun to actually deploy these because we know the machines themselves work really well? That would be very cool as well.
So starting with you, Ryan, can you give us or them more about your backstory? Specifically, what got you into materials or building or tools? And we'll move over to you as well. But yeah, what's the whole story of how you got here specifically?
Mm-hmm. Let's see. I've been building stuff since I was in elementary school with my family. My dad was a big craftsman, so we've always had a shop with tools, and that kind of led me into engineering in college, where I was part of the University of Southern California's rocket propulsion lab, And that's where I started really working with carbon fiber and learning about the material properties. And at one point, when we were part of the student group, we got a call from a large aerospace company that told us they were doing a freezer cleaning. And they said, if nobody comes and collects this material, we're going to have to throw it all away. And I thought that was just crazy. So we went and picked it up as a student group. And that was the material that we used for the next couple of years. But it got me thinking at the time, hey, there's got to be a business opportunity here to do something with this material instead of just letting it go into a landfill. And that's when I got to work pressing skateboards and learning how to make use of that material. Got started, we launched a skateboard on Kickstarter, and that kind of is what led us into carbon fiber manufacturing as a business.
That's cool. But you no longer sell the skateboards.
We still have a couple of skateboards, but we're starting to move out of skateboards and into larger scale manufacturing of other industrial products.
Yes.
And the ultimate goal of our business is, what are we going to try and do with millions of pounds of carbon fiber scrap? And so we've sort of pulled back from direct-to-consumer products and started looking more at contract manufacturing and business to business.
So I found out about Ryan's idea, the concept, and really the problem in the industry through one of our co-founders who was actually teaching at USC while Ryan was still there. I was working in healthcare software at the time. So if you were to tell me I was gonna stop doing that and go start a skateboard company, I'd be like, you're crazy. That's not gonna happen. And that's what it looked like, because that was the proof of concept, the way that we could show that we could take what was essentially trash and turn it into these really indestructible skateboards. And that was really the environmental aspect, the high technology aspect. I didn't have the background that Ryan had as far as a handy shop kind of thing. So it was a interesting challenge, learning very much about this tangible, creating a manufacturing company. I was always working in technology, software and internet and those kind of things. So it was really a problem that I really thought should be solved. I could see that Ryan's idea really was a good one, and joined the team to really help out with the initial technology around the Kickstarters. And when we had to pivot to actually doing the manufacturing ourselves, finding a location and getting a lot of that up and running, so that we could try and actually make this happen. And I knew skateboards was just going to be the first thing. There's so many other things that we could do. So that's why I got involved, and it's been a really great journey.
I love that story because also, like, when Shopify started, they were selling snowboards, and then they realized how hard it was to make a store, so then they pivoted. And so it's similar in the same vein that, like, you proved it out. Although I guess Shopify didn't really prove it out in that way, but it's cool.
Do you have any like data that you could give the watchers of like how much waste there is on carbon fiber? I'm sure it's a significant problem, but like, do you have any data or any fun fact that you can give about the waste of carbon fiber?
Yeah, we estimate that about somewhere in the range of 20 to 40% of the material used in the manufacturing process can be scrapped, depending on if it's high production volume or low production volume. And that translates to roughly 10 to 20 million pounds of material that ends up in the landfill every year from the US market. And in 2020, we collected and turned into product 10,000 pounds, and we did 30,000 pounds in 2022, and we're on track to crush that number in 2023.
Nice.
I know you have a very pragmatic approach when it comes to like build versus buy in your machines, and we went over this earlier, but like in your dream world where you have unlimited time and resources, like what machine would you build?
Oh, that's a good question. I see, Jason probably will chime in too, because we both have our own, we have so many machines that we want to build. But the way I see our company headed is in the automation of the material processing. And you'll see out there, there's a lot of manual work that we do right now. And so our vision is to take the team that we've got, and we're going to be a growing team, but train everybody that works with us how to run different pieces of equipment, and then automate the process so that the amount of material we can process goes through the roof. And we also have visions for taking our flat stock, robotically loading it onto CNC router tables and pulling it off of CNC router table, pulling cut parts off of CNC router tables, similar to the way that the robot tends the block production right now. We'd like to take that same approach with sheets as well.
So you could probably tell we've been thinking about this. We are constantly talking about how it's all about the volume. The problems there, the material supply for us is definitely there, and we're just barely scratching the surface of what is actually industry wide. And so what Ryan was describing are ways for us to automate, mechanize in some ways, but use robotics, those kind of things, so that we can really just, with the space that we have now or another space, try and increase that per pound per day, right size the labor, because it's not ever going to be just robots doing everything in this situation. There's a lot of operator time, really making sure that the quality is there, because it's a chaotic input stream. We always really need that, those eyes on the process, but making it so those people who are doing that job can just be that much more efficient with the time that they're putting towards it, because all of those resources are there to really just take what is essentially, you saw it, it's chaotic trash bags of material, or it's boxes of 80% not carbon, separating out that carbon. Just all the ways that we can use technology, and there's a lot of different technology we could employ to really just go. One of the great things that I'd like to see is that we are able to process a lot more material, but also bring the cost down. And that way the material is then available to new markets, new applications that, because of price right now, especially the aerospace grade pre-preg carbon fiber and its high quality, reasons it's used in that industry, just not accessible in a lot of product categories. So us being able to do the things that we can to basically expand the general market for that material. So that, Ryan, it's really a conversation that we try not to have because we know that we need to do it. Really, really want to do it. And we're like, okay, we know we want to talk about this. We know we want to do this.
Hours.
We can do it. We can go on for hours. Okay, we got an order.
One step at a time.
To process this order. Sure. And yeah.
No, I feel that. That's why I asked it, because as a software engineer myself, there's always things that I want to rewrite, because it for our use case or whatever. So I was like, I could feel it in both of you. I was like, they want to do things.
Yeah, we do. We have a lot on the development plate.
And luckily we're at a time where the advanced technologies around computer vision, actually being able to use AI in our particular process, because we could do things like scan the incoming material stream and do nesting and do defect detection. Those would be really, really helpful to, again, just keep that the volume increasing, help us do that.
Totally. That's cool.
Yeah, as engineers, we want to think about everything we can ahead of time. When we have a new idea, a new process, we try. But there's always going to be something that hits you that you weren't expecting. When you were starting out, or maybe actually at any time, what is the biggest challenge you feel that you've overcome as a company?
For me, I guess always our biggest challenge is we have an abundance of material supply, and the challenge has always been figuring out the best product to make with it. And so growing our manufacturing capacity, our sales pipeline, and our material supply chain all simultaneously, for the most part, bootstrapped or, low funding. So what we want to do is, bring on as much supply as possible. But if we have too much supply, then it will sit and go bad in warehouses, or we'll have to dispose of it. If we have, too much manufacturing capacity, then our costs will go through the roof. Mm-hmm. So we got to play that fine balancing game of growing all three of those things at the same time, while maintaining, positive cash flow and, development as well.
A lot of the viewers will see what we just went through and see all the tools and machines and think about how hard those things can be to make yourself or to work with them. But a lot of times the hardest parts are the stuff in the back, like the finances, the marketing, all the other things that go into a company. And so I'm glad that you pointed that out, is that it's not always just the machinery that's the hard part. In fact, that's the fun part.
That is the fun
You're
part.
Right. And
the one thing about machinery, I guess, is it always seems to take longer than you plan on it taking. I can knock this machine out in 2 or 3 weeks, and then 3 months later, you're putting the finishing touches on it.
I feel that with software too. It's like, I can get this done in a weekend, and then little thing. It's the last 10% every single time.
Mm-hmm.
It's because you have that picture in your head.
Yeah.
Right? It's just, it exists already. It just isn't in its final form. And actually, what you saw today does not include all the machinery and things that we've done that we actually have just stored and put away because it doesn't meet current customer demand. We had to try a lot of things, a lot of ways of doing this process or developing the processes. So that's interesting because it is challenging to put a lot of effort basically just trying to figure out what people want, what people are willing to pay for, and we could produce economically, especially with not a lot of resources to start with.
Yeah, and we do a lot of iteration. So, we're on press 6 right now. We've got designs for press 7 ready to go. We've retired press 1 and 2, and we'll just keep moving. We're up to router table number 5 right now, and we have 3 active router tables. The next thing will be water jet number 2, Haas or CNC machine number 2.
Nice. I love how you clarified just in case you all build your own or something.
Yeah, I don't know. It's kind of an interesting product, carbon fiber, in that it really needs to be cut on a piece of equipment that can cut metal, but it tends to work best if you cut it like wood. So but a wood machine typically may not have the best rigidity or the accuracy that you're looking for. So you want the accuracy of a metal machine with the kind of versatility of a wood cutting machine.
That's cool.
That's actually a really good question. Is that in what areas, even if it's not things that you two currently make, but what areas do you see carbon fiber like the most efficient, or it's like the prime suspect or prime,
the material
customer?
Of choice?
Yeah.
It finds itself in a lot of applications where you're trying to capture weight reduction, and you're looking for something that's extremely stiff. So things that fly, things where you're trying to extend battery life or get fuel economy are perfect candidates for carbon fiber. The trick is making it low enough cost that it works in those applications. When you're talking about drones and airplanes, the budget for building those things can be fairly large, so it makes sense to make carbon fiber drone frames, carbon fiber airplanes. Automotive is a trickier one because everything is really low cost in the automotive industry, but it's carbon fiber starting to make its way into that industry. And transportation is going to be a huge industry for composites in the future.
And for you personally, I guess for both of you personally, like what would you love to see come on your desk? What would you like to make
Oh,
out of
yeah.
carbon fiber?
So my background is in aerospace engineering and rocketry. So I would like to see our material go full circle, where we take some of our recycled material and are able to put it up into a satellite application and get it into space. You know, it makes the blocks in particular are a great opportunity for optics components because they have low coefficient of thermal expansion. So different sensors where you want low change in dimensions with change in temperature, perfect application for ours. And so it'd just be cool having that space and aerospace background to see parts make their way back into space.
I would
Only say, I guess our primary markets though tend to end up being sporting equipment and industrial bracketry.
Sure.
But dare to dream, right?
You're right.
I think I'd only expand on that in that those opportunities that also have volume, and we are seeing volume. We're seeing constellations. We're seeing, tens of thousands of satellites being launched in these constellations. And so if we could be a component in there, we would be able to actually move a lot of the material through. That would be both a really awesome application, really cool, and also help the mission.
So you mentioned earlier that you like to surf, and so I was wondering if you've ever thought about making a surfboard out of carbon
I
fiber?
actually have made some surfboards.
What?
Not anything with the material that we collect. All the material we get has got a resin already infused into it, and it would be pretty tricky to make a surfboard out of the carbon that we're working with, because it has to be cured under heat and pressure, and in most surf foams would get crushed under the heat and pressure
Oh, whoa, okay.
that we would cure the composite at. So I've done the shaping where you just cut the foam blank and then do a wet layup over the top of it.
That's dope.
And they're pretty fun. It's a lot of fun to make a surfboard.
And
That's
you
super
tried it as well? You used
It
it?
surfs pretty well.
Okay.
Okay, no.
I actually we used the blue insulation foam back when Home Depot used to have blue insulation foam instead of pink insulation foam. I don't even know if they have pink insulation foam anymore, but we shaped them out of blue foam and then laid fiberglass over the top and then did cool carbon fiber features in them.
That's dope.
Actually, it's actually in the break room. I can show you guys.
Okay, nice. That's so cool. Because I feel like it would be a good application because the thing that I hate about surfing is the board is so heavy. Maybe I'm just lazy.
So that's a one-off or a short batch, and in this specific instance, it's also a contoured product. So and with the core and everything. So making that a product line would be difficult for us.
Oh, yeah.
But there's definitely getting back to kind of like more of the fun engineering side of things. We've explored things like really incorporating as much digital upfront as possible into production methods. So 3D printing molds would be one of those steps. And there are companies out there that make very, very large 3D printers you could do that with. But if you were to 3D print an internal structure, and again, there's been companies that have worked on this issue, you could do that. What we're more likely to start with would be something where we would 3D print a mold or two pieces mold and make contoured parts, quick turnaround for a customer requirement. And if we have a customer that helps us with the financials of figuring out how to do something, and things like resin printed, UV curing resin prints, there are those that really do stand up to the temperatures and pressures. So we have looked a little bit into that. And as soon as we have a customer with a volume and the willingness to go through a development cycle with us, that would be actually really interesting, because then the range of different shapes that we make at that point really explodes. We don't have to mill it. We don't have to do subtractive manufacturing to make a uniquely shaped part. We can do, for instance, the marble, and actually shape the marble around a form and then you have something that's pretty close to near net shape. And I think that's a lot of what we would probably end up seeing. Or what we've talked about as well as actually using our marbled blocks to, and now that we have the mill, now we have that production capability, is we would mill molds. But all of those things usually translate into low production volumes, custom, and fun. But volume, actual pounds aren't. Yeah, that's really what we do have to focus on a lot of times. Is not always the funnest. It's what's going to actually help with this problem.
Right. So for all of our viewers, let them know how they can contact you, or if anyone has any more questions or has a request of carbon fiber, how can they contact you?
Yeah, the best way to get a hold of us is email, info@elevatedmaterials.com. We take all sorts of custom inquiries through that incoming email address. They can also reach out to the phone number on our website, elevatedmaterials.com. And we also have integrated quoting software on our website where anyone can upload a part file and get a quote turned around really quickly.
Yeah, actually on our website, as we were discussing, the block production of the marble style is
Forged.
Are we good?
It's got to be forged, right?
I like marble. You said marble a couple times, right?
Oh yeah, no, this is totally marble. I love it.
So as we were discussing, the blocks that we're making with this new forged or marbled look is something kind of new for us. So on our website, we're actually going to be coming out with new content about what's unique about this material, new ways of utilizing this compared to what were previously making, and so you could find that on our website as well.
Great.
And scene 5, rapid fire, take 1.
Okay. Other than carbon fiber, what's your favorite material?
Titanium
Nice.
or carbide.
Wood.
That's good.
So we talked about skateboards earlier. What is your favorite skate brand?
Probably loaded.
So after you've built a machine, like what's your preferred color of painting it?
Blue.
Oh, it's always.
So outside of engineering, manufacturing, what would your job be if it was not related to this at all?
Like totally out of space engineering and manufacturing, I would probably be in some outdoors space, like wilderness guide.
Nice. That's cool.
Photography.
Okay, so how long before you either get a machine, build it, or like get a robot before you put googly eyes on it?
So we had the googly eyes maybe the second week that we had the robot.
Nice.
Well, I mean, yeah, on behalf of us, I just wanted to say, thank you for your time and for everything. It's been awesome. I've really enjoyed it.
Yeah, this has been amazing. It's been great seeing behind the scenes.
Yeah, thank you guys for making the trip out to see us.
Of course.
Thank you so much.
We need the powder. We're all starting to sweat.
I was wondering if you guys would have the...
I know Demi that we used to have them, but do you think it'll make a significant difference? Because if not, you don't need to do it. But
Actually, no, I don't think so.
I think
Okay.
it will mix
Yeah.
with the sweat at this point.
Yeah.
Continuity issue.
that's right.
People would call that out on Reddit. For sure, they'd be like, wait.
We just lost shininess in a second.